Alright, day 3, we will continue simplifying expressions involving exponents. Some of these problems will be more challenging than some of the ones we've done before. Please put away your pencil. Do not copy off of me. Watch the video if you need a hint on how to do a problem, but then go back and do it yourself. Okay. Problem number 1. First of all, when you see a fraction times a fraction like this, please understand that it's really just like having one big fraction. Now, what I would recommend, let me zoom in a little bit more, is simplifying all of the numbers first while they're small. Now, I could multiply the 6 times -5 and get -30. 3 times 20 is 60. I could do it that way, but I prefer to simplify now. So looking at the 3 and the 6, alright, 3 goes into itself once, 3 goes into 6 twice. Okay, I'm reducing. Looking at the 5 and the 20, alright, 5 goes into itself once, 5 goes into 20 4 times. Okay, and I can even continue with the 2 and the 4 there. Alright, 2 goes into itself once, and 2 goes into 4 twice. So that's how I like to simplify the numbers first. Okay, so in the numerator, all I have left is 1. 1 times 1 is 1. 2 times 1 is 2. Well, don't forget this negative, so it's really a -1. Okay, so the numbers all simplify down to this. Now the variables. When you multiply a variable times another variable, the same variable, you add the exponents. So I'm going to have n to the -3 power. Alright, 6 plus -9 is -3. Same thing with the p's. Alright, p to the -7 times p to the 6. You add the exponents. So that's going to be -1. Alright, now looking at the n's, we still have this n to the 3rd power right here. Now, we know that anything that has a negative power is on the wrong side of the fraction. So these two things are going to have to move. So that means this is going to have to drop down, and this is going to go up. So at that point, we are going to have, so there's my -1 over 2 n to the 3rd. See, everything here in blue is not moving. But this p comes up and becomes p to the +1 power. This n comes down and becomes n to the 3rd power. So one final step. I don't really need the 1, so I can just write -p over 2 n to the 6th power as we add these exponents. And that is your final answer. Alright, now here again, I'm going to multiply the numerator together. Alright, 3 times 4 is 12, so there's that. Alright, n to the 6 times n to the 6 is n to the 12th power. You add the exponents. And then in the bottom still I have this n to the -3 power. Now, like I said before, anything with a negative exponent is on the wrong side of the line. So that is going to have to move to the other side, which in this case is up. So when I recopy, okay, so I've got my 12, right, sitting there, my n to the 12th power still sitting there, but my n to the -3 power comes up and becomes n to the 3rd power. Okay, so everything's in the top, so I really don't even need a fraction line anymore. Alright, so there's that. And when I go ahead and put it all together, for my final answer, I will have 12 n to the 15th power. Again, you're adding these exponents. Okay, so that is how you do that. Number 3. Now we know that anything to the 0 power is 1. So that whole numerator is just 1. Now, so far I've got this. 1. Now down here, I'm going to take this negative 3 power and apply it to each thing in here. Now if I were you, for a brief moment, I would just leave this as 5 to the negative 3 power. Do not try to do the power now. A lot of kids will, knowing that 5 to the 3rd power is 125, they'll think 5 to the negative 3 power is negative 125. That is false. This negative means it's on the wrong side of the line. That's all. It's not a negative number. We're just going to have to move it later. Anyway, so then we'll have n to the negative 3 power, which we'll just write down. And we have p. When you have a power to raised to another power, that's when you multiply. So this will be p to the negative 21 power. As we've seen on the previous problems, anything with a negative exponent is on the wrong side of the line. So this and this and this, all three of these terms are on the wrong side of the line. Okay, so they must be moved. So this is going to move up, and this is going to move up, and this is going to also move up. All three are going to move up. Now if we do that, okay, so like say there's my fraction line, then when this moves up, it's going to become 5 to the positive 3 power, and this will be n to the positive 3 power, and this will be p to the positive 21 power. Now everything's up. Now when everything's up, we don't need a 1 down here or anything, so really we don't need the fraction bar anymore. So this is what we have so far. Now when you have a power of 3 or 2, you should go ahead and do it. So 5 to the 3rd power is 125. Now if this had been a 4, 5, or 6, I would have just left it. Alright, so 5 to the 4 power, I would just leave as 5 to the 4 power. But 5 to the 3rd power, we'll go ahead and do 125. And I would suggest memorizing the first 10 perfect cubes. Alright, 1 to the 3rd power all the way up to 10 to the 3rd power. Because you won't be allowed to use a calculator often. So, this is our final answer. Right here. Okay. Alright, this is very similar. Once again, I'm going to take these powers and I'm going to do them to each thing on the inside. Okay, so I'm taking this 3rd power and I'm going to do the power here, I'm going to do the power here, and I'm going to do the power to this guy. Now, negative 3 to the 3rd power, alright, that's the 3rd power, so I'm going to do it. I know that 3 to the 3rd power is 27. Now, because it's an odd power, that negative stays. So it will be negative 27. If this had been an even power, like 2, then this would be a positive 9. So remember, odd power, the negative stays. Now, for the variables, you simply multiply. Alright, power to a power, you're multiplying. So I'm going to have n to the negative 21 power, and I will have p to the 15 power. Alright, now I'm going to do the same thing with the 7. Alright, I'm going to do the powers. And these are all variables, so I'm just going to multiply power to powers when you multiply. So I will have n to the 42 power, and I will have p to the negative 28 power. So this is what I have. Now that everything is out of the parentheses, I can go ahead and sort of combine these terms, well, not terms, but the variables that are the same. So what do I have now? So I have negative 27. Now these n's, when you multiply n times n, you're going to add the exponents. So this is going to give me n to the positive 21 power. All right, negative 21 plus 42 is positive 21. And now with the p's, so I'm going to have p, and I'm just going to add 15 and negative 28. So that'll be negative 13. Okay, now anything with a negative exponent, like this guy, is on the wrong side of the line. So in my mind, I'm thinking, all right, here's my invisible fraction bar. Everything starts out in the top. You know, it's understood. But this guy is on the wrong side of the line, so it's going to have to drop down. Okay, so at that point, notice this negative 27 is not going to drop down. A lot of kids will think, oh, well, so we're dropping negatives now. So if this is going to drop down, then this 27 is going to drop down too. Maybe even become a positive 27. No, 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 no. This is the same negative 27 that you've been dealing with since the 3rd grade. When you were in elementary school and you saw a negative number, and you know, say you got and you added two things, and they were the negative one was bigger, and you got an answer of negative 27. Did you suddenly go, oh, and so therefore that'll be 1 over 27? No, you never did that. Negative 27 was just a negative 27. You didn't move it or anything like that. The only thing that we're moving is when we have a negative power, a negative exponent. So this is not an exponent, so it's just going to stay right where it is. So back to business. So this will move down and become p to the positive 13 power down there. And everything else is going to stay where it was. So negative 27 n to the positive 21 power. And that will be your final answer. Right there for number 4. Okay. Number 5. Okay, when you have a fraction with a negative power, in the past I've said that you could do the reciprocal of the fraction, make this a positive power. But one of my students did it a different way. Her name is Natasha, and I like the way Natasha did it better, so that's how I'm going to teach it now. Natasha said, why not just do the negative 2 power to everything the way we did on the previous problems, okay, like I did with this negative 3. Why would we do it any differently? And I'm going to go ahead and agree with Natasha. So, Natasha's method, alright, I might have negative 4, see I've got my negative 4 there, and for now I'm just going to stick this negative 2 power on it. Notice I went ahead and put that that negative 4, you know, in parentheses. You should do that. So I've got my negative 4 to the negative 2 power, and then I've for the power to a power, I'm going to multiply that. So I'm going to have n to the positive 24 power. All right, and these are just variables, so I will go ahead and just multiply here again. So I will have n to the negative 6 power, and I will have p to the positive 10 power as I multiply. Okay, so now's the point where we look at it and we decide what has to move. So anything with a negative power is going to move. Okay, so this is on the wrong side of the line, got to be moved, and this has got to be moved. Okay, the other stuff is going to stay right where it is. So on my next step, okay, so I've got my n to the 24 power, that does not move because positive, and I've got my p to the 10th power, that does not move either. Now these two guys had to move. Okay, so this had to go up, and this has to come down. Alright, so if that happens, then I'm going to have n to the 6th power on the top, and keeping the parentheses, mind you, I'll have my negative 4 squared here on the bottom. Alright, I just move these two. Now we can go ahead and put things together and see what's what. So if I do that, all right, then I'm going to have now a variable times a variable, you add those exponents. So I'm going to have n to the 30th power. Okay, down here I can now that this is a positive 2, I can go ahead and just square it. Now because it's an even power, that negative sign is going to go away. So that will just be 16. Okay, so I've got 16. 16p to the 10th power. Okay, I think that is the most straightforward way to actually do the problem. Thank you, Natasha. So, number 6. It's ironic because Natasha doesn't watch these videos. So, unless somebody, one of her friends tells her that I'm giving her credit in the video, she may never know. Alright, we'll see what she says on Monday. Anyway, so again, I'm going to take that negative 3 here and apply it to everything inside. Okay, I'm just putting that negative 3 on everything. So this is going to be, I'm going to have 5 to the negative 3 power, and I'm going to have n to the negative 3 power. And similarly, I'm going to do the same type of deal here. Okay, so I'm going to have 5 to the positive 3 power. And I'm going to have n to the 18 power. Remember, power to a power, you multiply. So that'll be to the 18th power. Okay, so that is going to give me, well, anything with a negative exponent has to be moved. So this is on the wrong side, and this is on the wrong side. Whoops, didn't really mean to do that. Okay, so this is going to come down, and this is going to drop down. So everything that was in the top is going to drop down. So, alright, here's my fraction line. Alright, so my 5 to the 3rd power, alright, I'm just going to leave it like that for now. That's going to stay where it is, and my n to the 18th power is going to stay where it is. But this 5 to the negative 3 power had to drop down, like I said. So it's going to drop down and become 5 to the positive 3 power. This n is going to drop down and become n to the positive 3 power. When you have nothing up here in the top, you will need that 1, alright, to kind of hold that numerator. But I think we're ready for our final answer. So let's do this. Okay. Now, just like when we multiply variables, we add these exponents, we can do the same thing with this 5. So this will be 5 to the 6th power, alright? Notice I do not multiply the 5 times 5. I don't make 25 to the 6th power. It's just 5. Okay, so 5 to the 6th power I added right there. And in a similar way, I'm going to add right here. Alright, so that's going to be n to the 21 power. And we really can just leave it like this. This can be our final answer. Okay, 1 over 5 to the 6th, n to the 21 power. Now, if somehow you did this all out, like 5 to the 3rd power is 125. So maybe you did that. And then 5 to the 3rd power, again, is 125. So if you did 125 times 125, okay, then maybe you got this big old number, which is 15,625 and to the 21 power. So even with a bootleg 4-function calculator, you could come up with this number without too much trouble. So that's fine. I'll accept either one. Okay, so number 7. In an hour, I'm going to take my family to go see Ender's Game, the movie. I read Ender's Game, the book, and found it to be awesome. So, if anybody likes science fiction and you haven't read Ender's Game by Orson Scott Card, I would highly recommend it. It's one of my favorites. Anyway, doing this second power to everything, all right? Doing the power to this, that, and the other thing. Then that's going to give me 25, all right? Positive 25, all right, because negative 5 squared. And then n to the 8th power, multiply, and then p squared. All right, so that was relatively simple, but there you go. Number 8. Okay, I'm going to do this negative 2 power to everything that you see here. So I'm going to get, so I will have n to the negative 10 power, because you multiply power to a power. And then I will get p to the positive 8 power, multiply. Now this 3, for the moment, I'm just going to leave it as 3 to the negative 2 power, all right? Because I'm doing that negative 2 power to everything. And then I'm going to have n to the negative 2 power. And I will have p to the negative 4 power. I am multiplying. I am multiplying. Okay, so this is what I have. Now, as you've seen many times so far, hold on, my color, I changed it by accident. Anything with a negative exponent is going to have to be moved. So this has got to be moved, this has got to be moved, and this has got to be moved. Oh, and this has got to be moved. Everything except for the p to the 8th power has got to be moved. So, that looks like this. Alright, so you see my p to the 8th power unmoving. Okay, but everything else is going to be on the other side of the line. So this is going to drop down, of course, but then this has to go up, and this has to go up, and this has to go up. So, okay, let's start with the n. This n to the 10th power is going to come down. Alright, so I'll have n to the 10th power. Alright, this goes up, so I'm going to have 3 to the positive 2 power up there. This is going to go up, so I will have n squared, and this is going to go up, so I will have p to the 4th power up there. So obviously everything you see here in pink just moved. Alright, so these three things are now up here, positive powers. This one guy is now down here. So now we just clean it up, and that should be our final answer. So, okay, 3 squared. Let's go ahead and do that, because the exponent is squared or 3rd power. I say do it. Now, with n squared, well, look, these n's, as I look at, let's see, I feel like I should change colors. When I look at these guys, all right, n squared, and then n to the 10th power on the bottom, these are going to cancel with each other, okay? I'm going to wind up with n to the 8th power in the bottom. Okay, like that. Now, I encourage you to think of it this way. Okay, when I look at this, n squared is n times n. Alright? Now, n to the 10th power is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's n to the 10th power. So what's really happening is these two n's are canceling out 2 of these n's. Alright, there were 10. I just canceled out 2 of them. That leaves 8 behind. And they're on the bottom. See where they are? They're on the bottom. So that's why I have n to the 8th power on the bottom. I don't recommend writing this out all the time. You see how tedious that was. But if you picture it in your mind, I think you can do it. So that's why it's n to the 8th power. Anyway, the p's, of course, I'm just going to add these. So I will get p to the 12th power. And that is our final answer. Okay, let's go to number 9. All right, number 9. Again, when you have a fraction times a fraction, it's really just one big fraction. So I've got these parentheses here, so I would like to go ahead and deal with that first. So I've got 3 squared. All right, so look, up here I've got my y to the 12th power, and I've got my 27, and I've got my x to the 18th power. All right, fine. Down here, I've got 3 squared, that's 9. And then x to the 3rd power squared, power to a power you multiply. So that'll be x to the 6th power, and y squared. Okay, and then I'm just going to bring down my x, y to the 6th power. I just brought that straight down. Okay, that's fine and dandy. So just cleaning this up a little bit. So in the numerator here, I'm just gonna redo the order is all. I've got my 27, I've got my x to the 18th power, and I've got my y to the 12th power. Okay, I just put it in the order that we usually do, alphabetical order. Now, so I've got my 9. Okay, that's great. Now, as far as the x's go, check it out. We've got x to the 6th power, and then we've got x over here. So if you put those together, we're talking about x to the 7th power. So there's that. Okay. Meanwhile, if you look at the y's, I've got y squared, and I've got y to the 6th power. If I put those together, then I've got y to the 8th power, all right? Because you add those exponents when you do a variable times a variable. So this is what I've got so far. This is number 9, so I don't know why I've got an 11 creeping in on me. It doesn't belong here. Okay, ignore my friend. So now just simplifying stuff like you do. 9 divides evenly into 27, all right? 9 goes into itself once. 9 goes into 27 3 times. Okay, so when we really are ready for our final answer here. Just going to put a line. So here comes the final answer. All right, we've got 3. Now we're canceling like I showed you before. The 18 minus 7 is 11. So this is going to be x to the 11th power. But I encourage you to picture 18x's over 7x's. These 7x's will cancel out 7 of these x's, leaving behind 11. Similarly with the y's, I'm going to have y to the 4th power in the top. Again, picture 12 y's and 8 y's. These 8 y's are going to cancel out 8 of these y's, leaving behind 4 y's. Since everything's in the top, I don't really need anything in the bottom. So this is my final answer for number 9. Okay. Number 10. Well, before I get too carried away, anything that has a negative power we know needs to be moved. So this is going to have to drop down like so. Okay. Now I could reduce these. Should I reduce these now? Both of these are divisible by 2. So if I divide this by 2, I get 3. If I divide this by 2, I get 4. All right, so 8 over 6 becomes 4 over 3. So this situation is going to become, all right, so I've got my 4 over 3. I've got my n to the 3rd power. I've got my n. I've got my p squared. Okay, I just copied all that stuff down. But my p to the negative 4 power drops down and became p to the 4th power down here. So then I'm ready for my final answer. Okay, so I've still got my 4 over 3. Now these n's, this n is going to cancel one of these out, so I will have n squared. These p's, you add those powers, so I'm going to have p to the 6th power. And that is the final answer. Number 11. As I do this 3rd power to everything inside of here, then what I recommend is for a moment, just write 4 to the negative 3 power. We'll deal with that later. And then for the variables, you multiply. So I've got b to the negative 6th power, and I've got c to the negative 3 power. Now, we have learned that anything with a negative exponent is on the wrong side of the fraction and must be moved. Now, I don't see a fraction, so it's understood that everything is in the numerator to start out with. So all 3 of these things, alright, this guy, and this guy, and this guy, all 3 of those things are going to have to move to the other side of the line. Okay, so this is going to have to drop down, down, and down. Alright, so if we do that, we will get 4 to the 3rd power, and then b to the 6th power, and c to the 3rd power. Alright, with nothing left up here, we're going to have to put a 1 to hold the place. Alright, and then we can go ahead and write our final answer. We decided that if it's the 3rd power or the 2nd power, we should go ahead and do it. So 4 to the 3rd power is 64. Alright, you should memorize that. B, and then just copy down b to the 6th power and c to the 3rd power. So that is that. Alright, number 12. Okay, anything with a negative power is going to have to move. So this is going to have to move, and that is going to have to move, and this is going to have to move. Those 3 things have to move. Okay, while we're at it, we might as well reduce. 2 goes into itself once, 2 goes into 6 3 times. Okay, so here's what we have so far. So I've got 1/3. Okay, now, alright, so this b to the 2nd power goes up. This is going to go down, and this is going to go down. Okay, so this, okay, let's get that c. This didn't move, so I'm just going to put that where it was. C to the 3rd power stayed put. Okay, this went up, so I'm going to have, alright, so I'm going to have b to the 2nd power now in the top. These 2 move down, so b to the 5th power, I'm going to have that down here, and c to the 6th power, I'm going to have down here. You know, once we move them, the exponents are then positive. Otherwise, I'd have to move them again and again and again. So now let's just clean this up, and that should be our final answer. Okay, so I've got b squared. No, I do not have b squared. Scratch that. So I have 1/3. So there's that. Now looking at the b's, these 2 b's cancel out 2 of these b's, and that's going to leave b to the 3rd power in the bottom. Okay, one more time. When I do that, what we're picturing is this. B squared is like BB. B to the 5th power is B, 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 B. So what's really happening is these 2 B's are canceling out 2 of these B's. So that leaves 3 B's, B to the 3rd power, but notice they are on the bottom. So that's why I have b to the third power on the bottom. Alright, I recommend that as opposed to trying to subtract and figure out where everything goes. Just move things and then cancel things. That's it. That is the preferred Burton method. Okay, so this is going to become c to the 9th power. And that's it. Because there's nothing else in the numerator, I really need that 1 to stay there. So this will be my final answer. Alright, brilliant. Number 13. Anything to the 0 power is 1. Now this 0 power only pertains to the y, nothing else. So this is going to just become 1. So basically I can ignore it. Now, so that leaves the 5 and the x to the negative 3 power. Now, x to the negative 3 power is on the wrong side of the fraction. So, when I make my fraction, 5 is going to stay where it was, up top. But the x to the negative 3 power, that's going to have to drop down. And so I will have x to the positive 3 power down there. So that is the final answer. Okay, that's number 13. Number 14. I'm going to take this power of negative 2 and stick it on these three things. So for a moment, I will have 5 to the negative 2 power. And then I will have b to the negative 2 power. And here I'm going to multiply these 3 times negative 2. So I will have c to the negative 6 power. Now, anything with a negative exponent has got to move. So that means this, and this, and this. Basically, everything is on the wrong side of the fraction. Everything is going to move. Okay, so this c is going to go up, this 5 is going to go down, and this b is going to go down. So if I do that, alright, the c goes up, so I will have c to the 6th power. The 5 goes down, so I'll have 5 squared. And the b goes down, so I'll have b squared. Okay, so since this is less than 4, alright, we will go ahead and actually do it. If this had been 5 to the 4th power, I would leave it. Alright, but 5 squared, we will go ahead and do 25 b squared. So that's it. This is the final answer. Alright, number 15. None of these parentheses have powers on them, so I can go ahead and sort of deal with this right now. 3 times 7 is 21. Alright. N to the 4th times n to the 3rd power is n to the 7th power. P times p to the 5th power is p times p to the 5th power is p to the 6th power. And you know, that's it. That's the final answer. Here again, there are no exponents on these parentheses, so I can go straight ahead and do this. So 4 times 5, so I've got 20. Alright, when you multiply variables, you add the exponents. So I'm going to have b to the negative 4 power and c to the 3rd power. I mean, if you need to, you can think of that as c to the 1 power. I personally find that quite silly. Now, b to the negative 4 power. Anything with a negative exponent is on the wrong side of the line. So that is going to have to drop down to the bottom. So here's my fraction bar now. The 20 is going to stay up at the top, alright, because here's our understood fraction line. That 20 is going to stay at the top. This c to the 3rd power is going to stay at the top. But the b, as we said, is going to drop down and become b to the 4th power like that. So this, my friends, is our final answer. Okay, no exponents on the parentheses, so we can proceed. Negative 2 times 6 is negative 12. X to the 5th times x to the negative 2 power is x to the 3rd power because you add. Y to the negative 3 times y to the negative 2 is going to be y to the negative 5. Again, you add. Anything with a negative power is on the wrong side of the invisible fraction. Okay, the invisible fraction is right here, understood. Okay, so this y term is going to have to drop down to the bottom. So I am going to have my negative 12 x to the 3rd power over, okay, y to the positive 5 power. See, it dropped down. Notice I do not move the negative 12. Once again, a lot of kids will think that, oh, we moved the y down because it had a negative, so the 12 is going to move too. No, no, no. We only move things that have negative powers, negative exponents. Negative 12 is not an exponent, it's just a regular number, so it will not move. It stays where it is. Okay, let's go ahead and this parenthesis, these parentheses, there's an exponent, so I'm going to do this power to everything inside of here, like so. So I'm going to have 16. Okay, might as well go ahead and do it. 4 squared is 16. And then for the variables, I multiply. All right, power to a power, you multiply. So this will be x to the negative 6th power and y to the 10th power. Okay, you multiply. Now anything with a negative exponent is on the wrong side of the invisible fraction line, which is here. And thus will have to be moved. So this x to the negative 6th power is going to have to drop down. And that will give us our final answer of the 16 stays put, the y to the 10th power stays where it was, but the x, alright, so I will have x to the 6th power down at the bottom. And that is the final answer. Okay, these parentheses have an exponent on them, so I'm going to have to do this power to everything inside. Okay, so when I do negative 3 to the 3rd power, I get negative 27. Notice that because it's an odd power, a negative will stay negative. Also, notice I don't multiply. It's not going to be a 9. Alright, it's a regular number, so I do 3 to the 3rd power. Now with the variables and their exponents, you multiply. Alright, a power raised to a power, you multiply. So I'm going to have k to the negative 18 power, and I'm going to have n to the negative 24 power, and p to the 3rd power. Alright, I did the 3rd power to everything inside. Now everything with a negative exponent is on the wrong side of the line. So these two things are going to have to move. Here's the invisible fraction bar. So this k is going to have to drop and this n is going to have to drop. But notice the negative 27 is not an exponent. So even though it's negative, it's going to stay right where it is. So I will have, why did that do that? Hold on. So I will have negative 27. Okay, that stays where it is. The p to the 3rd power stays where it is in the top. Okay, but these other things. Alright, so I'm going to have a k to the 18th power on the bottom, and I will have my n to the 24th power on the bottom. And this will be the final answer to number 19. Alright, this is the last problem. So if I have a negative fourth power on these parentheses, I will do the negative fourth power to everything on the inside. So for a moment, I'm just going to write 2 to the negative fourth power. For the variables, a power raised to a power you multiply, so I'm going to have n to the negative 12th power and then p to the negative 8th power. Okay, now, as we've discussed many times before, anything with a negative power is on the wrong side of the fraction and must be moved. So in this case, all three things are now on the wrong side. So there's an invisible fraction bar right here because everything starts out in the numerator. But now all three of these items will have to drop down. Okay, so what I'm going to have is I'm going to have to keep a 1 in the top sort of as a placeholder. But now in the bottom I will have 2 to the 4th power and n to the 12th power and p to the 8th power. Alright, and we decided that if you have the 4th power or greater, we can just leave it like this. So it's fine if you want to go ahead and leave this as 1 over 2 to the 4th power, n to the 12th power, p to the 8th power. Now I happen to remember that 2 to the 4th power is 16. So if you chose to put 16, that's fine, but you're allowed to leave it as 2 to the 4th power. Okay, and that is the last problem. Okay, so this was a good sampling of everything we've learned so far. So please make sure you can do every problem on this worksheet without copying off of me, without using your notes. If I were you, I would print off a blank copy of this and do it all over again and see if you can get 100%. I'll see you on the next video.